Welcome to this Eureka webinar in association with Maxon. My name is Paul Fanning and I'm the editor of Eureka. Today's presentation is called Agriculture 4.0 and Drive Technology and will be presented by Martin Leahy, Maxon's sales engineer for Ireland. Now, before I hand over to Martin, I should just let you know that if you have any questions during this webinar, please type them into the box on the right-hand side of your screen. We will attempt to deal with these questions at the end, but if we don't have time, we will hand those questions on to Maxon and they can be answered offline. And with that, it simply remains for me to hand over to Martin. Martin.
Hi, Paul. Thank you for the introduction, Paul. My name is Martin Leahy. I'm the Maxon sales engineer for Ireland. And today I'll be presenting the webinar, Agriculture 4.0 and Drive Technology. So just a little bit about Maxon first. At Maxon, we develop and build electric drive systems. We combine brushed and brushless DC motors, gearheads, sensors and controllers into mechatronic drive systems. We also have ceramic injection molding and metal injection molding departments to complement the business. Worldwide, Maxon has about 3,000 employees at 9 production sites, and it's represented by sales companies in over 40 countries. So of the 3,000 employees, 200 work in R&D, and Maxon places a massive emphasis in research and development, and 8% of the total revenue flows in here. So R&D is responsible for not only ongoing improvement of manufacturing processes, as well as testing systems and obviously new product development. So what is Agriculture 4.0? So the first agriculture revolution occurred when humans started farming around 12,000 years ago. Agriculture 2.0 started from the 17th century onwards, and that followed the end of feudalism in Europe. And the third, also known as the Green Revolution, was the introduction of chemical fertilizers, pesticides, and new high-yield crop breeds alongside heavy machinery in the 1950s and 1960s. So now we're at Agriculture 4.0, and this is the latest revolution. So the term is a little unclear and it's frequently referred to as many other names like smart agriculture or intelligent agriculture or digital agriculture. I kind of tend to avoid the term smart and intelligent agriculture because it kind of implies that current agricultural practices are not so clever or not so smart. So in order to avoid a little bit of conflict, I won't use them in this presentation. So the fourth agricultural revolution, much like the fourth industrial revolution, refers to the anticipated changes from new technologies. So in the case of agriculture, it's particularly the use of AI to make smarter planning decisions and maybe power autonomous robots and machinery that could be used for mundane tasks like growing or picking or weeding or distributing agrochemicals, etc. So as you can imagine, there are many facets to Agriculture 4.0, and there's definitely not enough time to cover them in this webinar. So given the nature of Maxon's experience so far, I will primarily be focusing on the use of AGVs, AMRs, AUVs, and kind of automation-intensive applications like vertical farming. So what are the drivers and barriers associated with Agriculture 4.0? I think we're all well aware of the stat that the world population will reach about 10 billion by 2050, and food production will require a 70% increase in order to meet this demand. This challenge is also exacerbated by resource depletion or climate change, as well as increased pressure on arable land reserves due to urbanisation. What's also become very topical is labour shortages in the agri industry, and future-proofing agri-enterprises against labour shortages. Yeah, it's become increasingly topical, especially during the coronavirus pandemic. And finally, just eliminating repetitive mundane tasks through automation can also offer farmers an improved work-life balance and give them more time to concentrate on continuous improvement of the agri-business. So some of the barriers, well, I know in the Irish scenario, anecdotal evidence that kind of suggests that farmers in Ireland are definitely risk averse, and investing in capital intensive, novel, and sometimes very complex technologies can most definitely be perceived as a barrier. Some additional barriers include the current level of government support and regulation, and I will touch on this a little bit further. Farmers and food producers can operate in quite an insular environment where kind of negative experiences with complex technologies are well documented, and they will travel through the community rapidly. And yeah, so agri-robotics is already showing tremendous progress in seeding and weeding applications, and agriculture is the world's third largest market for professional robotics behind industry and logistics. We are currently seeing massive growth in this market, and autonomous and remotely controllable agri-vehicles and machines are becoming part of everyday life for more and more farmers and food producers. So let's look at our first system, which is the automated guided vehicle, or AGV. So what is an AGV? Well, it was introduced in the 1950s in the automotive industry, and AGVs are primarily designed to transport or tow materials. They have a major presence in logistics, and they allow goods to be moved within a given space without any human intervention. So thanks to a multitude of sensors, the motor can adapt to ground conditions. An AGV robot is probably clever enough to use simple sensors in order to avoid hitting obstacles that pop up in its way, but it's not clever enough to kind of go around them. So let's consider the two types of guidance systems associated with AGVs. The first, of course, is wire guidance. So the AGV moves by following a path plotted on the ground. This normally kind of includes buried wave-emitting wires or metal rails, or even underground electric wires, etc. So the robot detects the signal transmitted by the path, and it follows it as if it's kind of on a railway track. So implementing this movement technology and modifying the path in any way afterwards requires a good deal of work. So wire guidance is therefore suitable for simple applications, but it definitely does not offer a whole lot in terms of flexibility. The second system I want to consider is OptiGuidance. OptiGuidance is a less expensive, kind of simpler alternative to wire guidance, and it allows the AGV to use onboard computers to follow a painted line on the ground. This solution will fall short of total flexibility, but it doesn't require the same structural or infrastructural work that's associated with the wire guidance system. So just to recap, with minimal onboard intelligence, the AGV in its most basic version can only obey basic programming instructions. With wire guidance, its movements are limited to fixed routes, and the slightest modification of these routes will involve substantial work and sometimes interruption of production. So the AGV can detect obstacles in its path, but it cannot bypass them. So if the path is obstructed, it will stop until the obstacle is removed. So let's look at our second type of agri-robot, which is the AMR. So the AMR, or the autonomous mobile robot, is a more autonomous and flexible robot, and it won't require the same startup costs associated with AGVs, and it also relies on more sophisticated technologies. Again, there's two types of system I want to consider. The first, you'll see on the top right-hand side of the slide, is a LiDAR system, or a laser guidance system, and this system allows the AMR to move thanks to a network of reflectors integrated into its environment. The robot is equipped with a rotating laser. It moves using the principle of odometry and uses the reflectors to define its path. It's easy to modify the robot's path using the supervision software that's included with the system. And laser guidance is currently one of the most reliable technologies on the market for AMRs. And the second type of system I want to consider is the geo-guidance system. So this system requires a map of facilities to be created, but it does not call for infrastructure development or work like the LiDAR system or the laser guidance system. The AMR can find its way around autonomously, and it can calculate its path automatically. The advantage is that the mapping of the robot's operating environment, it can be modified at any time. So it's kind of therefore a very highly flexible technology. So these autonomous robots, the AMRs, the dynamic digital maps and onboard cameras, and they use laser guidance. They rely on data from the cameras, built-in sensors and laser scanners, as well as their sophisticated software to detect their environment and choose the most efficient path to their target. The advantage of AMRs is they can be quickly configured and easily reprogrammed, and it simply requires a change of their path on the digital map for them to kind of react to accordingly. So on this slide, you can see the Perseverance rover. So the Perseverance rover landed this month on February the 18th, I think. So Maxon did more than 100 motors on Mars, or the red planet, and kind of much like agriculture, the conditions are incredibly harsh. The drives have to withstand cosmic radiation, dust storms, and even temperature fluctuations. So the Perseverance rover, in this case, which is a fancy AMR, is taken with it 10 brushless DC motors, 9 of which are a brushless EC32 flat, and they're also taking a brushless EC20 flat, which is combined with a ultra performance planetary gearhead. So AMRs would typically be used in applications such as field robotics to do mundane tasks, again, as like planting or spraying or weeding or harvesting and soil sampling, etc. So now let's take a look at AUVs. The market for AUVs or aeronautical unmanned vehicles is very dynamic, and it's very young also. So and it's expected to grow rapidly, and especially on the back of the coronavirus pandemic. So agri drones, they serve two main purposes. One is to capture the aerial imagery and provide real-time data on crop health and herd health. And the second is for selective spraying techniques. So the drones, they have the potential to improve the chemical spraying efficiency. Selective spraying techniques that require fewer chemicals, and which has kind of knock-on effect of environmental and economic benefits. And they'll also see a reduction in water consumption. One of the other added kind of benefits of using the AUV is that you've no heavy machinery on the soil, so you're avoiding any additional soil compaction also. So there's huge potential for UAVs or AUVs in agriculture, and I think in the Irish context, one of the kind of interesting ones that came out of it was the hill farmers in Ireland who are farming sheep, for example. They basically retired the sheepdog, and now they're using drones for herding flocks and performing head counts, etc. So the Irish Natura and Hill Farmers Association came out and they've seen the potential, and they've called for the Targeted Agriculture Modernisation Scheme, or TAMS funding, to be extended to also include the usage of drones. So the TAMS funding or scheme kind of will offer grant aid of 40% towards the total cost of certain investments. And even in the case of young farmers, they might offer up to 60%. So again, Maxon cater in terms of drive requirements. Maxon really cater for all the drive requirements for UAVs, and this includes payload mechanisms, drone motors, controllers, and even propellers. So let's move on to vertical farming. This is very interesting, I think. So vertical farming is the practice of growing plants in fully controlled conditions and usually stacked layers, and it's under artificial light or in the absence of sunlight. Again, vertical farming enterprises are typified as having large capital outlays and high day-to-day operational costs, and labour remains the single highest operating costs for even the most well-capitalised vertical farms in the world. So automation and economies of scale can aid in minimising operational costs, as well as aiding in also the elimination of pests and diseases that might enter the vertical farm through human transmission. So it's for this reason vertical farms, especially level 3 vertical farms, which are highly automated, are very interesting in terms of automation. One of the things with vertical farms is that although it's technically feasible to grow most crops, not all crops are economically viable. So 57% of indoor farms produce the expensive leafy greens like lettuce, obviously as most consumers will buy on price. The technology is relatively immature also. There's around 30 hectares of indoor farming worldwide, and when you kind of compare it to the 5 million hectares of conventional farming worldwide, yeah, it's minuscule. Some of the benefits though, like you have increased yield. It can be 300 to 400 times greater per square yard per year when compared to conventional farming techniques. And some of the additional advantages include food has the ability to be produced close to the customer, and this will obviously decrease the food miles or the logistical costs. Again, some of the drive requirements we're interested in are the dosing pumps, the fans, and with vertical farms, you'll also have harvesting or picking and seeding and weeding robots also. So we'll move on to some technical considerations. So you started your project and you've defined your drive requirements, and you now need to move on and build a working prototype. So some of the things you'll need to know is you'll need to know how fast and which torques does the load move, how long the individual load phases last, what accelerations take place, and even how great the mass inertias are. So apart from that, what are the other things you should consider before selecting a high precision microdrive supplier? First of all, a single source supplier for your drive system, it might prove invaluable in the long run. Apart from the obvious cost reduction by combining all the products together, and you'll have economies of scale, which will lead to a reduction in costs. And there's other things to consider as well, like, for example, all the expertise will be for the entire drive system will be under one roof, and this will essentially prevent jumping from pillar to post between suppliers in order to meet the project requirements. Some of the other technical considerations you need to look out for are, do you need a long service life? There should be no compromise on safety or quality. Lower power consumption might also become, and high efficiency might become particularly relevant, especially when you're designing battery systems. Okay. So some of the other technical considerations, you need to consider your IP protection and your operational safety. Agri environments, as I mentioned earlier, are incredibly tough conditions for motors to work in, and to avoid any risk of a fire outbreak in case of water seepage or damage due to dust or dirt, it's definitely advisable to choose maybe an IP65 protection rating. So this will essentially guarantee complete air tightness and very satisfactory water tightness. So with the IP65, the first digit refers to the device's ability to withstand solid objects. So in this case, it's a 6, which equates to the product is completely dust-proof. The dust cannot enter the crevices, and therefore it cannot damage or soil it internally under any circumstances. The second digit is the resistance to liquids. So in this case, it's a 5. So this means the device is protected against water projections. There's other things to consider also when selecting a drive. You have to consider operational safety. So when you're working with or operating motors or any other type of electrical equipment, safety must come first. Good design and component selection will prevent the risk of serious injury or damage to expensive equipment. So with most motors currently on the market, temperature sensors are outside the motor on the housing. So this can often lead to overheating and delays in securing the motor and electronics, and consequently there's risk of fires. So to counteract this, the IDX motors has 2 internal temperature sensors in 2 areas, the motor itself and the electronics area. So therefore, if a problem is detected, the motor will immediately go into safety mode, and without giving the entire casing time to heat up or basically cause fire. So finally, in terms of operation, you might have to consider the ambient temperatures. Maxon suggests a range from -20 degrees to 100 degrees Celsius. But they can also offer greater capacity on this. So modifications can be offered to allow the motors to operate in temperatures beyond this range. And this will include adjustments to the PCB, grease, cables, etc. So you've decided you want to buy, or you want to design, I should say, a battery-powered device. What are kind of some of the technical considerations here? Well, first of all, Maxon began its journey into the world of power storage with the development of the bike drive. It's essentially a retrofitting kit that turns a regular bicycle into an e-bike. So after some difficulties with the battery supplier, Maxon decided to go out on its own and build its own batteries. Of course, this is a lot easier said than done, and manufacturing batteries requires a good deal of engineering creativity, technical knowledge, and most of all, kind of specialized equipment. So you want to design your battery power pack. So what do you need? Well, you'll need to know the required capacity of the battery. You'll need to know the required voltage, the continuous current, as well as the maximum current and duration. And you're also going to need the time allowed for charging, as well as the number of cycles or service life. Yeah, and it's also important to note that a battery pack just isn't finished here after the cells have been professionally glued and wired. A battery management system, or BMS as it's called, is also required. The electronics are usually installed on a PCB in the battery casing, and Maxon have developed and produced their own BMS. So the BMS ensures that the cells are charged and discharged evenly. So Maxon are they're very well equipped for the production of prototypes and small output quantities. So let's look at some actual drive solutions from Maxon. So the first of which we'll look at the IDX here again. So just to cover all bases on the IDX drives they kind of stand out for their high torque density. To use a brushless motor. They're also available with a brake and absolute encoder. And the absolute encoder will eliminate the need for homing procedures. Maxon also realized that kind of responsiveness and short lead times is expected as standard with these solutions, especially when they're going into the AGV or AMR sector. So they guarantee a delivery of the IDX solutions within 19 days. So when you place an order for an IDX motor, you can define all the parameters online through our online configurator. You can define how the product communicates, what cables are needed, the electronics you choose, the motor power, the encoder, and whether or not you need a brake, etc. So you can program everything online to the point that the motor is delivered, ready to use or plug and play. So if you don't want to go down this route, you can also talk to your local Maxon representative who will essentially just walk you through the process. So the second product I want to take a look at is the latest controller from Maxon, which is the Minimax. And this has been specifically designed for the AGV and AMR sector as well. So the size of the controller itself makes it suitable for system designers who develop or who want to develop compact and autonomous robots or shuttle systems. And with the Minimax, it's a low-cost controller and it can control up to 4 axes, and this can also be expanded modularly. Now, the controller contains power amplifiers for 4 brushless DC motors, or alternatively for 6 brushed DC motors or 3-stepper motors. And it's now available up to 60 volts and 10 amp per drive. One of the significant advantages is that the controller is freely programmable with the comprehensive APOS IDE automation software and the license-free motion control library, which is written in C. It's also possible to run complete processes or sequences autonomously with this controller without the use of a PLC or PC. And some of the suitable applications include, I guess in the agri terms, include delta weed picking robots, AUVs, AMRs, as well as XYZ positioning tasks. The next one is kind of one of my favorites. It's the Maxon wheel drive. And the Maxon wheel drive was specifically developed as a compact solution for AGVs and self-driving vehicles in primarily the intralogistics and industry, and it's now being used for outdoor applications like field robotics. And some of the advantages include that it's highly efficient, it's compact, it's modular, and it's highly reliable. They use an EC90 flat motor, which is mature technology. So this motor is basically tested within an inch of its life. So like the IDX also employs mature motor technology. So the wheel drive system allows for 27 Newton meters of continuous torque, or up to 70 Newton meter peak torques. And the nominal speed is anything from 20 to 290 RPM. The wheel diameter is 160 millimeters, but the wheel is optional. If you don't require the wheel, yeah, you can still purchase the Maxon wheel drive. So the system has IP54 protection, which is probably primarily for indoor use, but it also comes with IP67 protection, which will be for outdoor use. So yeah, let's move on to unmanned aerial vehicles and what Maxon is offering in this department. Maxon, first of all, guarantees the unrivaled quality of its efficient, reliable and powerful drive systems for the aerospace industry. So dedicated aerospace specialists support our customers from the specification phase right through to production and beyond. So obviously unmanned aerial vehicles, as you can imagine, require very reliable components, and above all, they have to be energy efficient. So this will ensure the longest possible uptime. The safety requirements for unmanned aerial vehicles are also under constant scrutiny or review, and Maxon is well equipped to deal with these new regulations that might be put in place. They have their EN 9100 certified since 2012. So this standard was created especially for companies that develop and produce components for the aerospace industry. And Maxon has the necessary quality drives and knowledge to develop specific drone motors that will meet these requirements. So on the bottom right-hand side of the slide, you can see the Mars helicopter. And Maxon's experience was really to the fore here, and this was particularly evident with the Mars helicopter, and it took an enormous engineering effort. The thin air on Mars is comparable to conditions on Earth at an altitude of 30 kilometers. And even accounting for the reduced Martian gravity, the helicopter has to be particularly light. In this case, it's about 1.8 kilograms, and it can obviously only carry small batteries as a result. So the components used here are incredibly energy efficient, and the helicopter in this case is using the DCX 10S motor for control of the Mars helicopter swash plate. And these motors are obviously modified to suit the Mars environment, but the winding technology, I believe, is still quite the same. And these motors are online configurable from the Maxon website, and again, you can configure everything and it'll be delivered within a lead time of 2 to 3 weeks. So let's move on to the next slide. I just want to consider a couple of case studies now. So the first of one is the Davidi Rover. And Davidi Rover is a global leading innovator in high precision winery applications. Development of this robot was done because I had to mow about 2 hectares of land, and obviously this wasn't a very easy task. Also, the soil in vineyards is very unstable, and it's actually quite similar to the surface of Mars. So initially, Davidi Rover, when drafting the first design specifications, they actually collaborated with the European Space Agency, or ESA, to review their designs of all the robots that were developed for the Mars missions. And so this robot has to negotiate rocky, steep terrain, and it's exposed to mechanical stresses every 12 seconds on average. And kind of as a result of these requirements for motorization, the Davidi Rover came to Maxon to develop a kind of bespoke solution. So the mechatronic solutions, they're a result of a partnership between Davidi Rover and Maxon France, and this has been going back a period of 8 years. So the motor is driven by 4 DC motors, 1 per wheel, and these are brushed, again, DCX 22L drives that offer maximum power density in a very small kind of installation space. These motors are highly efficient, which is very important for battery operation. They're also combined with a GP32 ceramic gearhead. and this solution enables the mower to absorb the load on the wheels and deliver the torque required for traction. But this wasn't the greatest challenge. The greatest challenge was actually the three blades. The high load tended to damage the ball bearings of the motors, and this led to failures. So the Maxon went back to the drawing board, and the engineers came up with an aluminium bell housing for sustainable production. So this collaboration, it's been a long-term partnership, and I thought it was quite interesting that one of the Maxon France employees came out with the quote, "Our role is not just limited to delivering electric motors. Instead, we supply complete solutions that fulfills the need of the customer." So yeah, we'll move on to the next case study, which is, again, a very interesting one. It's the Hanover Housing Association Moss machine. So this is kind of like almost like a vertical farming application. And it's a unique vertical greening system for watering moss mats. So how the principle behind the patented idea of the vertical greening system works is that a moving sprinkler arm not only evenly moves up and down over the moss surface, but it also kind of vibrates or shakes a little during the gliding motion to ensure that each and every millimeter is supplied with water. The excess water then flows into a steel tray surrounding the moss and is recycled. So this means that irrigation is optimally controlled without watering the surrounding area, which is efficiently closing the environmental cycle. So what's interesting about this case study is that due to the challenges of it being an outdoor application as such, corrosion resistance and wear resistance and long service lives are essential. And Maxon came up with using ceramic components and established Maxon drives assembled together to create this unique solution that offers a long service life and reduced maintenance. So that's kind of the end of my webinar. I hope you have plenty of questions to ask, and I look forward to providing some answers.
Thanks very much, Martin. Yeah, we do have some questions here for you. I'll go through them now. First of all, do you think that agri-automation will result in considerable job losses and further urbanisation?
Yeah, this is kind of an interesting question. I remember reading an article that labour in some farming applications can take up to 50% of the overall cost. I know in Ireland, the labour shortages have been kind of well documented. So in some cases, the labour is not even available. So there's no jobs to be lost. And using robots for kind of the mundane tasks like seeding or harvesting or watering, it decreases the need to hire these employees for the monotonous tasks. Instead, you can redeploy the employees to sort of more beneficial tasks, or I think even under current EU regulation, we're going to see more of a focus on environmental tasks. So that might even include, planting trees and particular types of plants, with an environmental focus. Okay. So I guess to kind of cap it, there might be some job losses, but really with good regulation, you can kind of redivert these job losses into other areas. Okay.
Next one was, how can government support the introduction of eco-friendly technologies in agriculture?
Yeah, this comes back to kind of two methods. First of all, the EU, I know in our context, wants to be climate neutral by 2050. So in order to achieve this, governments will have to play a major role in Agriculture 4.0 and have to provide access to capitals and route to market. So in Irish terms, agriculture is the largest contributor of greenhouse gases, and it accounts for over 30% of the total emissions. So in order to regulate, there's two main methods you can do. You can have the carrot, which is the capital incentives, or you can have the stick, which is your regulatory. So I guess this will all come down to regulation and capital incentives, and the common agriculture policy is going to evolve, as I mentioned earlier, with more of a focus on environmental tasks, which should really support the use of Agri 4.0 technologies.
Okay. And is it viable to adapt these technologies in developing countries? These technologies?
Yeah, this is another one that's kind of interesting. It's kind of a difficult one to answer as well, and there isn't a quick and fast answer. Like in some developing countries, like drought is a major issue, and vertical farming in these scenarios might provide, especially when I know there's only 30 hectares of vertical farming in the world at the moment, but when this increases and we get up into the hundreds and thousands of hectares, economies of scale will be at play, and yeah, the expertise will be shared between all nations. So yeah, probably in the short term it's going to be tough, but in the longer term it might actually be the only option in some scenarios.
Okay. And finally, does Maxon offer a sealed UAV motor?
Yeah, I think if you look at the slide, this is an interesting one. If you look at the slide, they're open motors. So the motors are almost, the propellers provide a sort of a forced ventilation, which means you can run the motors at higher currents, which means you have higher torque, which will also have the added on, you'll have a more compact motor then as a result. So it won't use as much of the battery. But if there's certain considerations or there's certain conditions where an open motor just won't be viable, the humidity will be too high or it'll be too wet an environment. And in this case, Maxon can offer customized products where the catalog product will obviously not meet the requirements.
Okay. That is all we have time for today. But as I said, any other questions that have been asked, we will pass on to Maxon and they can answer you offline. And with that, really, it just remains for me to say thank you to everyone who's tuned in today. And thank you very much to Martin. Thank you.
Thank you, Paul.